forward, there I will take the notes of that. So where is it? Random model. There it was made it. This is Randn. I'm going to take it. Very, very easy, not a difficult. And moreover, I want to tell you one serious point about it. This Rand and uniform are basically deals with, because this two random module, I want to make it very clear, not at present, not at present. Just to see the output of that. Just to see the output of it. I'll be making very clear when I come to data visualization, especially for this part only. Especially for this part only, try to understand this part, the Rand uniform, Randn and normal. These four things you'll get very good clarity when I come to visualization. Because at present I cannot go for introducing visualization. There I am going to explain in detail about matplotlib. In every batch, it is like that only. First, I'll give you the functionality, how they are working. And in the visualization part, I'm going to explain about matplotlib. There, I'm going to explain to you people. So coming to this point, when you come to this a small diagrammatic representation, which is kept in front of you, a small diagram only I'm showing. With the sample data, I will explain to you in the further classes. So, as far as this diagram is concerned, the values which we got it by using what? A Rand function with what next? Uniform function. Uniform function. The values which are available with this kind of thing is going to plot what type of thing? Uniform distribution. Right? I will go for taking some sample data, sample statistical data I will take, sample statistical data set I will take. From the sample statistical data, I will name the problem, and that problem I will apply this Rand and uniform, and I'll write the diagram of it. Okay, now I will find out some facts or some insights I will find from given data. I'll take the same sample data. I'll apply for normal distribution. For normal distribution is concerned, I will apply. There I'm going to take about the, see, one standard line is showing, right? This is called mean entered, mean. That is the mean. It's a one peak point that is. And this is left side, some values are available. X, X plus, X, some constant value, X plus some value. Like that, it will be going on coming. Suppose a mean here, 0. And I'm taking here -5, -4, -3, -2, -1. 0, 1, 2, 3, 4, 5. This is the deviation among these numbers also I will explain. There I'm going to take about some sample data. There the sample data I will submit to what? Sample statistical data. I will submit to what? Rand n. This n stands for what? Normal distribution. And next I'll go for what? Normal also will be there. Normal. Like uniform here, normal. Like Rand, and then here what? Randn. As far as outputs is concerned, you don't get confused, because that both of them, even in the interview point of view, you have to explain through diagrams only. That part I will explain in the data visualization. Once again, I'm making it clear. Okay, now, will you understand? Shall I move forward? Now, online students, online students, Pravalika. Hello, sir. Notes I am getting in the form of HTML. See, ma, I tired in explaining the notes. I tried in explaining the notes. I don't have the patience to explain the notes again and again. I tried. Really speaking, I tried in giving the notes, how to get the notes and everything. So I don't have the patience to tell the information now. So I tried in explaining the notes. Still, you people are not able to get it. So still, it's helpless. So my dear students, I already said how to download the notes. I already said don't make me to irritate again and again by asking the same question. How to download the notes, getting HTML format. I already explained in the class. Yesterday also I explained. Okay, now. So coming to the point of it, messages are coming to, sir, everyone message is coming on the display, hiding the screen. So here, 1 minute more. Okay. So now let us coming to that, Pravalika. And I said the notes how to receive it. And I already said, and don't ask the notes related kind of thing. And I already yesterday explained, multiple days explained. Google link how to download, Google Classroom also how to download. I already said in the class. Don't make me to get again and again the same story. Now I'm going to enter into further. A small example I would like to give you here. Just to try to follow. This is what I explained to you. Regarding the normal distribution, the other part of it, I will show you within few minutes. So today I'm going to enter into where next? What is that now? Randn. So Randn I'm going to explain now. So let us start discussing about the Randn. Syntax also I'm going to show you. What is the syntax you try to observe? Go to the Python environment. First of all, this random module is very, very important. That is going to come in the data visualization. But once again, I will revisit. Today, I'm just saying that how the values are displayed. Inside of that, there are mean is there, standard deviation is there, variance is there. After explaining statistical operation, once again, I will revisit because it's not a joke to understand these topics. So, as a part of my class, simply if I take this, what is that number of approaches? If I write up to here, you don't know that. But when I'm covering this, you have to carefully try to receive my notes, need to practice it, all the things to be done. So I'm going to enter into where? Next I'm going to say what? Rand. I'm going to take Randn. So last class I did go to the help. Import. Now what is this now? NumPy as what? NP. NP. So I'm going to write it help of NP dot randn. NP dot random. NP dot what? Random. Dot what? Randn. Randn. So this n stands for what? Just tell me. Normal distribution. Be careful. Rand, rand n. Rand of rand n. Rand n. This is strictly deals with what? Uniform. This is deals with what? Normal distribution. Total problem is different. Okay. Next, in connection with what is available here? Uniform, uniform, and next here it is what? Normal, normal. So these are completely different. These deals with a normal distribution. This deals with uniform distribution. What is the difference in that? I will explain with by simple case studies to you. Right now, see the functionality. Here, observe it. Randn method of what? Built-in function Randn, and it is a method. D0, D1, Dn. Yesterday also Rand also same na? Rand also same thing is taking. That's what I am taking. Return a sample or samples for the what? Standard normal distribution. Earlier one what? Standard uniform distribution. Both of them I will give you right now. Don't worry. As a part of that, as a part of that, mean will come, median will come, standard deviation will come, variance will come, lot of calculation. After that calculations, once again I will revisit my calculations. Okay, now? Right. Now see students, I'm talking about, here I'm going to talk about, see if you go for that, there is a version called what? Mean is coming, variance is coming, lot of other points are coming. Without telling this mean, variance and all those things, I cannot. Only thing is today you understand only one point. How the values are coming, you understand. Creating an object, you understand. Rest of them, I will take care about it. Because it's not one day or something. D0, D1 are called what? Int. Int. That is optional, they are saying. Z, it is an ND array or single float value will come. Single float value will come. Let me go for an example, you see. Let me go for an example. What is this now? NP dot random of what? Randn. Some random value will be coming. Some random value will be coming. See this now. NP dot random of what? 2 comma 4. Last class also 2 comma 4 means 2 rows and 4 things. So let me go to our case also. Today you understand how they are functioning. Later I will take care about in detail once again. Today I am talking about only 10%. Further after statistical thing, in depth I will explain. By writing histogram, all those things I will explain. By explaining histogram with a normal distribution, histogram with a uniform distribution, perfectly you will understand. Right now, don't make me to enter into that area. Even if I enter, you cannot understand. So let us start taking about that. So I'm taking what is this now? Create, or otherwise I'll take it. Import numpy as np. Now I'm going to write it. Create, create an object of, create an object of nd array, nd array by using a rand function of which one? Random module. Rand n function of, random function of what? Random module, random module of numpy, of numpy. So how do I write it? So there I will write it. A is equal to np dot, np dot, whose syntax if you want I will write it for your quick response. Variable name is equal to nd np dot numpy dot random dot rand n, rand n of what? D0, D0, D1, D2, so on. It is taking like this. I'm taking. So now I'm going to take it random dot. What is this now? Rand n, rand n, and try to print this data. You are going to get it type of A. It is going to give you the float value. It output also either float value or ND array it is coming. It is generating a single random value. It is generating a single random value. And they did not give you the value which is going to come. Rand will say what? Between 0.0 to 1.0. But this is going to give you different values. Different values. Because in the further when I'm going to talk about it, in the normal distribution, you will get the curve like this. You will get the curve. This curve is called bell, we can call bell. And this is a peak point is considered as a mean. Peak point is considered as a mean, for example. This is called -4, -3, -2, -1. And this is 1, 2, 3, 4 here we can call. So this places variance required, mean is required. Some small explanation I will give you. There are a lot of discussion is there with you. Almost in one entire class, I'll talk about this visualization. Because in EDA projects, this part is very important. That's why I'm specially concentrating on this. And sometimes you'll get negative value also when you are continuously running. Negative also will be coming. Are you following this? Negative also will be coming, but the Rand will not give you negative values. Did you observe that? Rand will give you constant values with positive only, but Randn will give you negative value. Just now I said 0 left side negative, 0 right side positives. But you that point you observe it is enough. Online students, I hope you are following me. Try to say last and final, you are going to get what? 0. There is some variation is there in this explanation. Go to the next area. See, my dear students, I am writing here. I am writing here 4. What is the meaning of 4, ma? What is the meaning of 4? 4 random values. Same like rand yesterday, what you did? Same thing with what? Rand n. But there you got 0.0 to 1.0. But strictly you will get it what? Negative values also will come, positive values also will come. That variation, that variance, standard deviation, everything I will tell you. So here I am going to have it. What is happening? Observe it. Some of them are negatives, some of them are negatives, some of them are positives. I'll put a graph for the samples, which will give you what? Normal distribution always. Bell curve will come. Why that normal distribution? I'll give you perfect example. You will understand like anything. Okay, now, right now, I'm going to take it one more students. I will take some six samples. I will take it. Six samples. I will take it. The six samples. So here, some of them are positive, some of them are negatives will come. All of them negative also may be coming, no issue. But when you go to Rand, it is completely giving you what? Positive values only. But here, some of them are positive, some of them are negatives will be coming. Are you following? Right. Let us move to the further. This ND array printed or not? ND array. Either float value as a result or it is going to be ND array. Even the help also is shown you. Even the help also is shown you. Z returns either ND array or what? Float. Either I can pass single value or group of values I can pass it. Yes. Go to the next, my dear students. I'm going to take up. Here I'm writing. Here I'm writing. I'm saying here the next value is called what? I'm saying there 2 comma 3. I am going to write it 2 comma 3. What is the meaning of 2 comma 3? 2 rows and 3 columns. Out of that, some of them are positive, some of them are negatives. And always observe, guys, 0.0 will be there, 0.0 left side will be there, 0. Right side also will be there. 0.0 left side is called a negative, 0.0 right side is also there. You can imagine the graph also. That is always going to show you one normal distribution curve. It will be made. And why that normal distribution? Very good clarity I will give you. Next, I am going to take up one more kind of thing, last and final. 3 comma 3 I will give you. 3 comma 3 I will give you. Some of them are positive, some of them are negatives. Understood? Right. Dear students, last and final. If I take it, only what? Rand you take it. Rand you take it. All of them are positives only. Okay, now? All of them are positives means there is some uniformity is there in that. The graph itself should come in your brain. Okay, now? Right. Rand n I am taking. Rand n I am taking. I am taking 2 comma 3 comma 3. Rand n is equal to 3 comma 3 2 comma 3 comma 3D this is. And as you already aware of it, 3D. Some of them are positive, some of them are negative. And behind this scene, I will give you a very clear cut knowledge after explaining statistical operations. So, if anybody asks you, what is the difference between Rand and Rand N? Rand deals with uniform distribution. Always positive fractional values will be there. Positive floating point values will be there. Randn will contain what? Now, deals with normal distribution. Some negative values, some positive values. 0 left side negative, 0 right side positive. That demonstrates the normal distribution. The 101% doubt is what? What is the normal distribution? What is uniform distribution? I'll give the best examples for you with practical environment. Okay, now that a normal distribution and then uniform distribution is very, very important in data science analysis part. That will give you perfection. Already it is there in your statistics. You studied. But do you know that? Don't know. But I will give you very perfectly. I'll give you. Right now, don't worry about it. This is called what? Randian. Clear? Right. Now, go to the another flexibility here. I will take up students. If you understand me, Rand related thing I will carry, guys. Rand related things I'm going to carry. Right? You please observe it. For your notes purpose, I am preparing. This function is used for generating random floating point values. Come on. Between 0.0 to 1.0 earlier one. Now I'm going to say random floating point values for standard normal distribution. For standard normal distribution. This what I want to say. Earlier one is called what? Uniform distribution. Uniform distribution that I need not to mention it. But here I'm mentioning that. Syntax number one, numpy dot random dot randn, generating any random floating point value, between, I'm not writing it. That random floating point value can be either, come on, positive or what? Negative. 0 left side, 0 right side. Do you remember that? It will be more clarity. And syntax number two, randn of what value? Generating random floating point values. That means in number of times. That is, of course, value times. For what purpose? For what purpose? Normal distribution. Normal distribution. For the normal distribution, and they can be, and can be, and can be either what? Positive or negative. Negative. That I'll take care. Three, random, same. Generating number of random floating point values, rows and this one. And it can be same wording I can give you. Positive or negative in terms of what? With a 2D. With a 2D. With a 2D you will get it, rows and columns. Same. Rand n, I will take it. Number of matrices, that is a D0, D1, D2, etc. For that only it is coming across. Generating random number of values, floating point values. There I am writing. There I am writing. Here I will say. A number of matrices, comma, rows and this thing for normal distribution with what values? 3D. This is about the concept of what? Functionality only, I said, students. And regarding the working environment, please don't worry. I will revisit once again. Because if I don't tell at this point of time, you will forget in remembering number of approaches for NumPy and ND array object creation. I think you got it. Clarity is there. Positive, random will give you what? Rand will give you what? Positive. And rand n will give you what? Positive and negative. That itself will give you normal distribution. Rand will give you what? Uniform distribution. Just remember, I'll take care in my class. And it is easy. I'll take population of India example. Economy rate of Indian population I will take. Such case studies if I explain, you will easily connect to my examples. Well, students, now I'm going to enter into the next area. Normal, I will go for it. Normal, I will go for it. Shrikant, clear. Okay, good. Coming to next area, see students, help of np dot random dot normal, normal. The main intention itself says that small n, not capital, small n only, not capital. All the functions must be what? With the capitals. And last, what he is doing? What are you doing? Uh, Stand up. Last guy, what are you doing? Something you are doing by bending your head. No, no, tell me, what are you doing? Huh? Are you listening any sounds from the earth? Then what are you doing? Come here. Come and sit here. You do some experiment on the earth. So you tell me what facts you find out. Hmm. Actually, you're a good boy. I've seen you earlier. You used to sit here, no? Why you went there? Okay. But you are sitting completely different. Okay, no problem. Sit down. Now look at. So np dot random dot what? Normal. So you see that kind of thing. What is that? The built-in function normal. Normal method of NumPy. Normal. What is the value there? LOC. And the next is called scaling. That scaling is important there. That represents a variance. Have you heard about variance in our statistics? Huh? మీరు విన్నారా లేదా చెప్పండి నాకు. You heard. What is the use of variance? That we don't know. What is the standard deviation? Do you know? Have you heard about it? Yes. Do you know the purpose of it? No. Only we heard, but we don't know why it is used. Okay. Not an answer, not a problem. Draw samples from normal distribution. Normal distribution also known as what I said yesterday. Gaussian distribution. Compulsory questions. Compulsory question. When you go to data science, any kind of interview, this is compulsory for you. Right. This is also what is coming. PDF also will be coming. PDF means not notes. Probability density function. I will explain probability density function also. In where? Normal distribution. These are all. I'll go for it. Next, coming to the point of it. Here I'm going to show you parameters. Parameters you understand first. What is this now? LOC. Float or what? ND array. Like of what? Floats. Now, mean is what? Center of the distribution. Just imagine my diagram, students. Center of the distribution. Slowly, I will try to tune in such a way that you will follow me. So, this is called what? Center of it. It is called what? Mean. And left side, some values will be there. Right side, some values will be there. There is a constant difference between the values will be there. Here, as I said, -4, -3, -2, -1, 0, 1, 2, 3, 4. And you will come across this area, shaded area, I will indicate. And I will go for one more kind of shaded area, I will take care. What is the use of this area? What is the use of this area? This total symbol is called bell curve it is called. That I will show you with a case study. Next, scale, float or what? Array like this is a standard deviation. Standard deviation between two intervals, some value gap will be there. That is what I am going to say. Must be what? Non-negative. Non-negative means positive. -4 -4 plus 1 -3. -3 plus 1 -2. -2 plus 1 1. 1 plus 0 0. 1 plus that is -1 plus 0. -4 plus 1 -3. -3 plus 1 -2. -2 plus 1 -1. -1 plus 1 0. 0 plus 1 1. 1 plus 2 3 like that. That is called what? Standard deviation. Variance I will go for. Variance is equal to what? Square root of what? You will be getting. I'll tell you that formulas very perfectly. Don't worry. Size int. Couple of ints optional. Right? That you go for it. I'm going to take about ND array. Out is called what? Either ND array or what? Scalar. What is a scalar? What is a scalar? So, scalar. See this. Coming to the example, my dear students. Coming to this. MU stands for what? Mu. Mathematics. Mu. Those point probability density function. See, by seeing today, totally it is going to be cock and it's what? Greek and Latin only. But when I explain with the case studies, this mu symbol, this entire thing you will be getting like anything. That diagram is also there. They are writing one type of normal distribution diagram also. What is the diagram they are drawing? Histogram they are writing. Even I will also write histogram. These are all called confusing for you. Nothing to worry. See this. np dot random normal 3. What is the 3? What is the 3? ఇప్పుడే కదా చూపించింది. What is the 3? What is the 3 here? Just now I shown you. What is that? What is the scale default? 1. What they mentioned here? Scale. Need not worry about it. Size is called what? 2 comma 4. 2 comma 4. What did you understand? 3 and 2.5. Size is this one. 2 rows and something they are giving it. Let me go for entering into this Jupyter notebook. In this case, I'll show you our examples. Create an object of ND array. Create an object of ND array and see that what is happening. Create an object of ND array by using which function? Normal. Of which module? Random module. So I'm going to write it normal. Normal. What is that now? Low is equal to what? 0.0. And the next is called what? Scale is equal to 1.0. Come on, next. Come on. Size. Size is equal to what they written? What they written, ma? What they written? So They written size is equal to what? None. Size is equal to none. So try to understand. No doubt in that. Beginning, some complexity. But once you started understanding, you like that approach only. Correct? Now, no need to remember. Concept, if you remember, you can see the help. You can easily practice. Okay, guys. Look at A is equal to NP dot random dot normal. Normal. I'm not passing any parameter. What is the low? 0.0. What is the scale? I did not specify any size. None. It is nothing but our functions concept. These are called default parameters or not? And print A. Print A, comma type of A. Type of A. What is coming? One float value is coming. One float value is coming. When I will go for normal, when I will go for Randn, there is automatically giving in the syntax only. Suppose my mean is what? 4. My mean is called 6. 6 left side, 6 right side. That time, when I have a predefined mean and then some samples are there, I'll prefer to go for normal. If I want to go for mean to be calculated on the basis of samples, I'll go for Randn. Let us go for one more you specify. Here I am going to write it. Here I am going to say some 4. What is this 4? Here you say from 4 basis onwards it is going to come. 4 basis onwards this value will come. Again you try to write it. Again you try to write it. What the value will be coming? On the basis of it will be coming. What is my scale here? What is my scale here? So that scaling is going on adding and going on subtracting and then it is going on coming. I'll say something like 4 again. You see something like what? Scale adding, scale reducing. Scale adding is called what? Right side. Scale is going to be what? Reducing. So my value I'm taking is called what? 4. 4 plus values are coming. 4 less than values are coming. It is also clearly showing what distribution? Normal distribution it is showing. Regarding that, simply feel that one value left side, one value right side, one value right side, one more value right side of the 4. Are you observing that? Just observe the samples. Go to next. I am going to write it. 4 comma 2.5 you write it. What is the meaning of 2.5? So next one more kind of thing you take it. One more kind of thing you take it. I'm going to get it now this. So I'm saying that guy, Colte, Colte, who is that? Timanshu. Timanshu, sir, not getting clearly. I am not saying that nobody is getting clearly. That only I am saying. In further, you will get this data very clearly with the graph myself only. I am saying from half an hour onwards. Correct? Huh? But one thing you need to get it. When I say 4, when I say 4, I am saying that this is a 4. 4 left side you are getting some negative values or not? 4 right side I am getting some positive values or not? Just you remember the series observation. Rest of them I'll take care in the further eyesight. So here you try to see. This is called what? Float value. This 4 mean, median, standard deviation, don't worry. You try to observe it. Next I'm going to take up another kind of thing is equal to comma what I am doing. Size is equal to 4 I am saying. What is the meaning of that? 4 samples will come of what? 4 as a low. And what is this 2.5? What is that? Scale. What is the scale? What is the low? After explaining statistical operations with formulas, with the coding, then I'll come to this. So why I'm saying this at this level without you are understanding? Suppose if anybody asks you, what is the random module in NumPy? If you say my sir did not explain, that time you will feel that sir did not explain. That's why I'm explaining now without making you to understand where we can use it. Observe it. You observe it strictly. What is happening here? You observe. What is the center value here? It becomes small. You see this 0 value, 0.74. Just I am asking you to observe your 6th class, 7th class knowledge. Next, what is happening after that? Next, what is happening after that? Minus 0.29 will be there or not? And after that, next what will be there? Positive value, observe it, 2.27, 2.27. Next is called what? 3.30. Now there if I put a graph, my graph will start from here and it is going to be like this. It is going on moving it. And this will be considered as something. What it is something, which point to be taken, I will explain to you nicely. This is one of the diagram called a normal distribution. That's what I'm saying. You don't get any panic when you are going to get it here. If I say something like 7, you observe it carefully. All positive values are coming. All positive values are coming. Here you observe something. Here also we are getting something. Depends on the scaling, depends on the number of samples. The values will be going on changing it. Now I will write it one more. ND array object you see. My interest is to make you to understand. Size is equal to what here? 2 comma 3. Size is equal to 2 comma 3 and try to observe it. Now I'm going to get it what? 2 comma 3. Next I'm going to take it. 2 comma 2 comma 3. And out of that you are going to get some values here. All positive values are coming. So when you get these positive scenarios, depends on the scaling, depends on the number of samples, all these things regarding this area. If we come back to this, which functions? Randian, normal, and Rand uniform. I have a separate discussion about 1 hour 45 minutes with graphs by taking sample case studies. But at present, you have to understand what? At present, you have to understand what? Rand and uniform gives you what? Positive floating point values, either single or what? ND array format. But when you go to random and normal, it will give you what? Random floating point values, negatives and positives. And these two deals with uniform distribution. These two deals with what? Normal distribution. Up to that, you try to understand. Later, I will take care in the further. No doubt in that. Some difficulty will be there. Some difficulty in understanding will be there. All of them keep aside. Now I'm going to take it. Uniform. This part I get it. I will take it. Next, what is the function name? Random. I will take. Here I'm going to take it. I'm going to get it. What is the next syntax here? Right. Instead of this place, I'll try to get it in one point. Instead of typing it there much a time, I'll get it from my previous discussion where I done it already. Here I will get it. There I'm having. In that place, random module is available. So there I'm having random operation, numpy random somewhere else. So random module distribution here. There I'm trying to show you one small point also I'm trying to say. Definition of what? Normal distribution. Please read out all of them once. Also known as what? Gaussian distribution is the probability distribution that is symmetric about the mean, showing that one minute, showing that data near to the mean are more frequent occurrence than data from the mean. That is the left side of mean and then right side of the mean. The normal distribution appears as a bell curve when graphed. Actually, this will be in the graphs. But at present, I said only for your object creation. Many things closely follow the normal distribution, like deciding the average height of the people, next size of the things produced by machines, and errors in measurements, blood pressure kind of decisions, and marks in a test. How do you decide the cutoff marks? All those things can be done. This is related to what? Normal distribution. Normal distribution. If you come to small example of what? Uniform and all, you also read out this uniform distribution. Come on, fast. In statistics, uniform distribution refers type of a probability distribution in which all outcomes are equally likely. Equally likely means same uniformity will be coming. If I show you the visibility, you only will decide it what is your normal distribution and uniform. In my class, all of them are reading the study hours. You only tell me. Now I am giving a things. All of them students are reading study hours, for example, is equal to 2 hours, 2.5, 2.3 hours, 2.3 hours, and then 3 hours, and then 3.45 minutes, 3.45 minutes, and next 3.50 minutes, 2.45 minutes, and 3 hours. Like that, they are going on reading. All of them are very close to what? All of them are very close to what? Between 2 to 3 only now. If I draw the graph that are showing the uniformity. Suppose some students are reading what they are reading 0 hours, 10 hours, 7 hours, 3 hours, 6 hours, 12 hours, and next is called some 19 hours and completely in the room only without coming out of it. Next is called some 3 hours, 1 hour, something like 9 hours like that. On and average, how many of them are reading? If I take it on and average, if I take it, this is my study hour. On and average, one figure will come or not. That figure is called x. What these values are called, ma? X minus value, x minus value. These are all called left side of these values or not. Some of them are right side of these values or not. Suppose on and average, they are reading 6 hours or reading some 8 hours. Less than these 8 values will come left side or not. More than 8 values will come right side or not. How my diagram is showing like this now? Is my diagram will be showing like this or not? Or is my diagram will be showing like this or not? It is irregular in format. But when this you take this format, if I put a graph, it is showing what? Uniformity it is showing. It is showing some uniformity. Uniformity showing. There is a slight difference in that I am saying. I think you got it. So this will give you close relation is there uniform. This is a rapid difference is there that is called normal distribution that I will show you with the case studies right now. Don't worry. Okay now, right, go. Let us move to the further. Online students, I hope I made you to satisfy. One more thing. A deck of cards has within it uniform distribution because likelihood of drawing heart or a club or a diamond or spade is equally what? Likely. Likely. So, see students, no need to have statistics knowledge. Usha, no need, ma. Who is having statistics knowledge? You tell me here, you tell me. Who is having statistics knowledge? Who is having? So, I don't expect you are having statistics knowledge. That's why, don't worry. I only will tell what is statistics, what is probability, what is this. And in depth, I don't go. Because if you want to go to statistics in detail, at least 45 days I have to tell you about it. But whatever the statistics I explain here, it is enough for you in the data science level. That is what I can say. Come on, next. Are you understanding this equally likely coming outcomes? Next, example of what? Uniform distribution. Uniform distribution. When a coin is tossed, when a coin is tossed, the likelihood of getting tail or head is what? Same. Either head will come or that is called which one? Uniform. Next, the graph of uniform distribution is usually flat. Do you know flat? What about the distribution of normal bell curve? Bell curve. There is some variation is there where the sides and the tops are parallel to what? X and Y axis. At least you understand 25%. But imagine the graphs. So rest of them I will take care. Okay now. Last and final example. You answer me. In a class of mine, almost 397 students in online. Saturday, offline students will generally go to underground generally. Only 30 members, only 20 members went to underground online also. Offline people, many of them went to underground because they are feeling project managers, team leaders, CEOs like that. So now tell me, in a class, out of 100 marks, all of them are getting 99, 99.5, 99.99. Like that, closely to 100 they are getting. What is the distribution? That's all. Easy. How to draw the diagram? I'll take care. Now, some students are getting 4 marks, 100 marks, 20 marks, 25 marks, 75 marks, negative marks also. When you go for JEE mains and all, negative marks also. What is the distribution? How do you put a diagram? On and average, how many people got a normal mark? Is it not called bell curve looking or not? So easily you can understand, students. Are you getting, students? Last and final. You take your career. You take your career. 10th class, you got 97, 97, 9.7 you got. 97% you got, for example. Intermediate, you got 50. Intermediate, you got first year 60. Second year 80. BTech first year 50. Second year 99. Third year 40. Fourth year, what is the distribution? Normal. You are maintaining constant graph. 95 percentage, you are 95, 94, 93, 95, 96, like that. Is it parallelly closely to each other or not? Did you understand this now? If you want to plot the data of closely related, likely, equally outcomes, I'll go for uniform. Totally random data, if it is available to make it as what? Some conclusions, if you want to prepare, I'll go for normal distribution. I hope you are at least understanding, I think so. Did you convince with my explanation? Right. Online students, shall I move to the further now? Good, got it. So normal distribution, bell curve, and uniform distribution, there is a parallelism, parallel flat curve will be coming on x-axis and y-axis. Just to remember my examples. Well, go to the further. Now I am entering into the this place. We did Randn also, other kind of things we discussed it. So students, I'm going to enter. Even while I am explaining this explanation, in any batch, I feel beginning some tough. Why? Students are keeping 10 question marks in the face. Later, slowly, when I'm coming to the end, they will understand. At least one question mark is there in your face. When I draw the diagram, you will perfectly understand. Shall I move to the further? Yes. So this is comes under what? Rand N and Rand N and normal. Rand N and normal deals with which distribution? Normal distribution. Random uniform generates what? Come on. Right. Will you remember that? How many types of data distributions? Two types. Number one, uniform distributions, normal distribution. We'll have some small awareness about that. Well, students, now I will move to the further. What is my next example? What is my next example? Go to that. I'll go for what? Shuffle. Shall I go to the shuffle? Yes. Let's start with the shuffle. Very simple. Shuffle is also going to be very simple. What do you mean by shuffle? You tell me. Just English meaning I am asking. Shuffle, shuffle, shuffle. Huh? It's a, it's shuffle the elements in list. Okay. I'm asking what is shuffle? Shuffle the elements in list. What a great students. Who is that? Usha. She's a girl. That's why I'm not saying anything. If it is a boy, na, I would have been given different answer. Okay, students. Amit, unordered element. Okay. Changing the order. Okay. Kalpak. I'm good. Okay. I satisfied. Okay. Rishi. No. Sumit. Up and down changing. Okay. So elements not in serial. Okay. Good. Interchange the values between them. Suresh. Okay. Good. Offline boys. మనకేం తెలియదు అసలు. Shuffle. Shuffling means what they said. I will also say my own answer. Reorganizing the elements of any iterable object in the same object. Reorganizing the elements of same element at the same address. That means immutable objects are not possible to reshuffle. Mutable objects only need to be reshuffled. because we are reorganizing the elements of a mutable object at the same address is called what? Shuffling. Are you following? Their answer also correct. My answer also correct. Your answer is silence. I don't know meaning of that. Silence is not indication of what? Accepting that you don't know. Come. Now I'm going to say create an object of shuffling. I will take it. I'll take it. Create an object of shuffling. I'll take this now. Try to go for it. What is this now? Shuffle. Shuffling, I'm going to take it. How you can go for it? Simple. A is equal to NP dot array of, I'm taking 10, 20, 30, 40, 50, 60, 70, 80. This is my data. Print of what? A comma type of A comma type of A. And it is ND array object. Type of A. Done. Now I want to rearrange these elements. How do you rearrange these elements? Come on. NP dot random dot random dot shuffle. Shuffle of what? A. So if you get like that, np dot random dot shuffle of A, don't think that A elements are shuffled and placed in where? X. Simple example is, playing cards now? You know how to play? Don't know? Don't think that playing cards is not a crime. Playing cards is a okay, no problem. But when you keep money betting and if you start doing that, that is crime. As long as you are doing everything in limits, no problem. If you take coconut water, a glass of coconut water, good to the health. If you take a tank of coconut water, it will give problem. Anything you do in your limits, no problem. If you exceed, no problem will come. Start. Shuffle will do the values rearranging in where itself? A itself. It is not going to keep it in where? X. What is the value of X? What is the value of X? Muddu Pavulu. X and type of X. So many times. Palpak M. Perfect. None. None. It is called none. None. Very beginning days also I said. What is that? X is equal to LST dot reverse. LST dot reverse. Reversing the data in where itself? LST. It never keep the reversed data in where? X. That Xi was printed. What it was? None. Explained how? That is there in the Python level only. Here also shuffled in A. Print the data. Print the data. Print of what? A comma type of A. You see that? Is it coming in the same order or a different order? Rearranging the elements. Rearranged the elements. Got it or not, students? Again you do, ma. Again you do. Again you try to do it. Again you try to do it. A comma type of A. Type of A. And ID of A. You see? ID of A. And try to do this. Again you try to do it. You try to do it. What is coming? To the same address it is reorganizing. Is it called shuffling or not? So what do you mean by shuffling? Rearranging the elements of any mutable object at the same address. Rearranging the elements in the mutable object, you say. That is going to be called as what? Shuffling. Are you following me? Good. Coming to the point of it, one more I'm going to take it. See guys, all of you. TPL is equal to Mahesh, jumbling, sir. Okay. If you say jumbling, all these things in interview, answers will become jumble. So jumbling is correct. But if you say such normal words, you cannot win the heart of the interior. You have to say what? Some words to be fixed in the brain. Keywords. Keywords are important. Correct or not? Yes. So tuple I'm taking 10, 20, 30, 40, 50, 60, 70, 80, 90. This is my data. What I'm doing now? NP dot random dot shuffle of what? TPL. I'm going to say TPL. TPL. What is the tuple? What is the tuple? First of all, students, TPL comma type of TPL. It is called what now? Immutable, correct or not? So this is, close the bracket. So this is going to be a tuple. And you try to do this. You try to do this. What is happening you see? Come on. Tuple object does not support item assignment. What it means? Rearranging at the same place is not possible. Rearranging means what? At the same object, you cannot assign the new values. So immutable objects are not possible to shuffle. Next, last and final, I will take one more example. Of course, this I will go for keeping an error. This big error I will try to remove from here. Keeping a comment, it is not possible to do it. Next, I am going to take it. S1 is equal to, if you are a good student, you need to answer 10, 20, 30, 40, 50, 60, 70. Set this is set type of what? S1. Type of S1. My dear students, set. According to your Python knowledge, set is mutable or immutable? Come on. Huh? Mutable or immutable or both are? Both. Now, first beginning you said some mutable or immutable. Later, slowly connect to the Python. Mutable or immutable or both are? Both. Now tell me, is it possible to shuffle? Is it possible to shuffle? Be careful. Don't tell whatever you like, students. I'm not here to accept whatever you say. Come on. Is it possible? Is it possible? Can I possible this 20? Is it possible to change my 50 to 60 in set? No, I cannot, because set never maintain indexing. Set never maintains indexing. I cannot do changes on this. So yeah, once you keep the set value, it remains same only. You cannot assign one value to left side, right side value to left side value to right side. You cannot reassign. So is it possible? Even though it is a mutable and immutable, when you say purely it should be mutable, then only it is possible to reassign. Then this also will give you the same error. Indexing is not possible. Also gives you error. You cannot do any indexing on that. This is also going to be called as what? Error. This is also not possible to do it. Got it out? So now, last and final. Actually, I want to finish it off. Now, last and final. D1 is equal to D1 is equal to n colon Python. Next, 20 colon Java and 30 colon C. Now tell me, print of what? D1 and what next? Type of D1 dictionary. Dict. Is dict is a mutable or immutable? Mutable or immutable? Mutable. If you say so silently, I will understand that you are danger guy. Mutable or immutable? Mutable. Good. Nice. Is it possible to exchange? Is it possible to rearrange? In the dictionary, whether you remembered or not, keys are what? Keys are what? Immutable. And values are what? Mutable, I said. Now, if you take an example, account number 10 and 1.5 is the balance. And next is called what? 20 is an account number, 9.5 is the balance, 30 is the account number, 10.2 is the balance, 40 is the 0.5 is the balance. It is a dictionary. What do you mean by word called rearranging? What do you mean by shuffling? Rearranging. So, he is a person having 10.2 balance. This balance is going to this balance, and this balance is coming to this balance. Is it allowed in instruction? Allowed? Come on. So dictionary is also not possible to reshuffle. Dictionary is also not possible to shuffle because keys remain same. If values are shuffling, it leads to one inconsistency in the data. That is also not possible to shuffle. That is also not possible to shuffle. My dear students, I am writing here. np.shuffle of what? D1. np.shuffle of what? D1 also gives you error. And interchanging law will be coming over there. Here what? Here error is going to come. keys remain same, and you are going to change the values. That will give you the problem. I think your understanding is also not possible. Finally, overall together, I'm concluding my sentences. What is possible, what is not possible. Last final I'm taking. This is what I'm taking in the moment. What list I'm taking. List LST I'm taking. LST. This I'm going to take it. Target also you change it. Bracket you change. And this also you do it. Now I'm going to take up LST, comma, type of LST. Type of LST, comma, what's next? Idea of LST you see. Idea of LST. Now you go for shuffling it. Shuffle it. Is it possible to shuffle or not? Yes, what should I do now? LST. And now immediately print what? Same LST again. After reshuffling, go to this place and see this data. Are you able to follow? Suppose you want to see multiple reshufflings. I want to see 5 varieties of shufflings. How do you do it? I want to do 5 varieties of shufflings. How do you tell me the logic? 5 varieties of shufflings. I just want to go for it. How do you? For yeah. For yeah. For J. No. Coming to the point of it. For I. Okay. I don't want to disappoint you on Saturday. For I in range of how many times I want to rearrange? 5 times. 5 times reshuffling. 5 times reshuffling. What I will do? NP dot random dot shuffle of random dot shuffle of what? LST. Now print what here? LST. Over. See that what is happening? What is happening now? This one is coming or not? Right. If you want, I will write in a systematically one more way. What is this now? For I'll say. What is this now? I will say here like this. Right like this. First time shuffle. Like this I will write it. Important this is. There I am writing. Dot format of what? You know. Format of what you know. Like this. I write it. I comma shuffle of it. See my dear students. 0th time shuffling. First time shuffling. Second time shuffling. Third time shuffling. Fourth time shuffling. If we don't want the 0th timing, you can say simply what? I plus 1 you add it. First 1, 2, 3, 4, 5 times shuffling will come. Are you following me? Last and final, one beautiful interview based question. How many ways are there to arrange my value called Mississippi? Mississippi. Gunshot question. I will tell you with what? Combinations, permutations and combinations also I will tell you. But at present I want to use my logic. What is my question? Number of arrangements of Mississippi. Number of arrangements of Mississippi. Number of arrangements of Mississippi. I am not going to the practical grounds of what? Mathematics. Number of arrangements of word called what? Mississippi. How do you take it? S is equal to what? Mississippi. Mississippi. Come on. Yes, Arun Kumar, follow my dear student. It is no doubt in that. It is an immutable object. Come on, apply your knowledge. It doesn't mean that when I am writing here NP dot, this one is giving error. See, if the question is that, it is error is coming. Error. Sorry. What is that? Yes. Yes. What is that now? Yes does not allow. Then what to do then? How can I overcome that? So remove that. I will apply my intelligence. Because we are intelligent. Because we know coding. Coding person can do anything. I'll convert into list. Yes. Beautiful. So Sumit. Super. Go for what? Convert into where? LST is equal to what? List of yes. My dear Arun Kumar. Come on. Are we doing or not? What is this now? LST. You print it. Got it or not? How many times? How many letters? Muddubavulo. LN of LST. How many? 11 times I will arrange. 11 times I will reshuffle. Come on. Code for what? Reshuffling. Come on. For I in range of LN of LN of what? LST. Beautiful. LN of LST. What it indicates? LN of LST means what? 11. 11 means what? 0 to 10 is nothing but 11 only, no? Right. Beautiful. Say what now? NP dot random dot. What is this now? Shuffle of what? LST. Shuffle of LST and print same to same. What I'm going to do? I will print first time this logic I'll write ma. This logic I'll write. Here I'm writing like this. I and then LST. You are getting the answer in list format only we are getting. See that we are getting in list format only I'm getting. Multiple times I'm getting in list format only, but I don't want to get it. I want to get in a simplest official format. If you remember my concept, you remembered, I think so. Come on to the basic example. Basic part I will cover. Testing. S is equal to what? Mississippi. Mississippi. Here I wrote it. LST is equal to what? List of what? Yes, sir. Yes, sir. Print of what here? LST. LST. You got this now. I want to prepare once again to what? String. What is this is called? What is this is called? String to where? Now LST to what again? String. What function I have to use? Join. Join. Already join explained. Already almost I said 16 to 17 functions explained. In string handling, చూపిస్తాను ఒకసారి. Because if we go to your regular sessions, string handling part 2, string handling part 2, string handling part 2, see how many functions explained. Join function also explained with examples, marvelous examples. Python coding, super, simply super, simply super. You are seeing here and there like this. More number of examples. This is what I explained it. Many more examples. Even Mississippi example also explained. That type of, if you read and come, nothing. I'll say what? Simply, I'll say not what? Join. Since we are the professional, I'll say what? Simply, answer is coming. What is the answer is coming? Mississippi. I just concatenated everything with what? Empty string. Are you following? Let's go to my example. I will go to this place. Such a beautiful thing. I am going to write it. What is this now? Dot. Hmm. Join of what? LST. Super. Simply super. See the answer now. What I got it. What I got it. See, all the combinations are coming. All the combinations are coming. Are you getting or not? That's all. Madam, number of combinations. Shuffling, rearranging. How many times? Length times. 5 or 6 or nothing. I don't bother about it. I will go for length. Automatically, my concept will take care. Are you able to follow this? Coding. Coding is important. Okay, now? Shall I move forward? Yes. So somebody asks you tomorrow, I have a string value. I want to reshuffle it. Is it possible to reshuffle directly? Directly not possible. Convert into what? Or convert into what? ND array. ND array you convert. Then you do what? Reshuffle. So that you can get the answer. Did you understand the shuffling mechanism? Right. Now I'm going to enter into the further things now. Go to this place. Shuffle I want to take up. Here I'm going to take fifth function. I will take it. Here I'm having with me. I'm having the shuffling mechanism. Here shuffle is there. Shuffle concept I will bring it. One more example also I'm having. That is only I said so far. Which mechanism I said so far? Only I said shuffling of what? 1D only I said. Shuffling of 2D I want to say. Shuffling of 2D, I want to say. Come on, mom. NumPy dot random dot shuffle of X. Here, X is an ND array object. Modify a sequence in place by shuffling its content. This function only shuffles the array along with the first axis of multi-dimensional array. Order of subarrays is changed, but their content remains same. I'll show you that. Subarrays are nothing but what? Further elements. Right now, don't worry. Even if I go for help also stream, help also np dot random dot random dot shuffle off. See, my dear students, this only I copied that only. Modify shuffle of X. This function only shuffles the array along with the first axis of multi-dimensional array. The order of subarrays is changed, but their content remains same. That you never bother. Now I'm going to say X stands for what? ND array or what? Mutable sequence. ND array is a mutable. That's why we are able to. List is a mutable. Tuple and all those things are immutable. Set and all. That's why not able to reshuffle. Got it all? Okay. Look at. I'll go to. Come on to the point. Another example. NP dot A range of what? 10. What it is going to give you? 0 to 9. Already A range is over now. What I am doing now? Shuffling. Shuffling. You carry this now. Take care. I'll go to this place. Here you arrange. Go forward. NP dot random dot A range of A and print what? A. After shuffle. After shuffle. After shuffle. Comma A, I wrote it. Before shuffle, I will write it. Before shuffle, I'll write it. Here I am writing. Before shuffle. So try to see the students. I'm getting what happens. Yeah. NP dot what? A range of 10. Shuffle. Why you are not saying that? You are also watching like, huh? So see, before shuffle, this is called my original elements or not? Now I'm going to, I shuffled it. Is it an arrangement or not? One more time you arrange it. One more time you call it. Don't expect in the same order they will come. Are you getting? Next, I'm going to take it one more example. 2D conversion. This is it called 1D or not? 2D. 2D conversion I'm going to take up. See my example, ma. A. NP dot Randint 0 to 101. 0 to 101 means 0 1 to 100. 1 to 100. Size is called what? 6 comma 5. What is the 6 comma 5? 6 rows, 5. 6 rows, 5 columns. Random values will come between what? 1 to 101. Between 1 to 101 random values. How many random values? 30 random values will come. In the form of what? 6 rows, 5 columns. Already ran it over now. Go. I will go for this one. You very useful examples. See ma, I'll take. Between 1 to 101, how many random elements? 6 comma 5. Okay. మీకు అర్థం కాదు కానీ I'll take like this. Because you are forgetting day by day and coming to the class. See, how many random elements will come? One random element will come or not? NumPy dot random dot. NumPy dot random dot. What is that? One value will come or not? Between 1 to 101, one random value. 28. One more random value. One more random value. I say, comma, 2, 3 random values. Between what? 1 to 101. 1 to 101. Again, 1 to 101. 3 random values. Again, 1 to 101. I will write it what now? 6 comma 5 I said. What is this 6 comma 5? Between 1 to 101, 6 rows, 5 columns. That is 30 random elements will come. Between what? 1 to 101. Don't think 1 to 101 minus 100 elements will not be coming. 1 to 101, any number will come 30 times of 6, 5 format. That is called what here? Type of A. It is going to be like this. That I am shuffling. Can I shuffle it? Yes. Go to that. I am going to. Don't think that if I run again, don't think that same elements will come. Don't think that same elements will come. Okay, now that part I am going to reshuffling it. That part I am going to reshuffling it. How do you reshuffle it? Reshuffle it. Go to the place. Here I am writing A. Here I am writing A. That you print again. That you print again. After shuffle, before the shuffle. Now see this now. Carefully try to see. Now try to run this. What is happening? This is my data. This is my data. What is happening? This is another data. You observe it. This is my elements which are available right now. This is called like this. Is it coming this place or not? Are you observing? 33, 33, which is available. It is available in the last but one. Here it is available last. It is available here. 31, which is went to last or not. 11, that is in the beginning. It will go to this place. 97, which is in the second. It went to where? Third. 56, that is third in place, came to second in place. Are you following? What it is doing? Shuffling. Subarrays. Subarrays is our list in list is called subparts that are going to deal with what? Rows only, rows only interchanging. That is what I am trying to give you. This function only shuffles array along with the first axis. First axis is nothing but rows only. The order of subarrays is changed, but their content remains the same. Rows only interchanging, their content remains same. Did you understand? That is the meaning of what? Which function? Shuffle. So only rows only changed, I said. Again, you need not ask, sir, rows changed, column changed. Rows only can be changed, but the entire row remains same. Are you able to follow? That is about which function? Right. Dheeraj, you are asking, sir, is there any way we can avoid the repetition of the number using Randn? You can use what is there, add to the set. Again, set element add to what? End array. Set eliminates what? Duplication. Duplication. You use membership operator. If you ask such doubts now, I will lose the confidence on you. I will lose the confidence on the candidate. See, if I go to that, if I go to this, for example, this is my data. For example, this is my data. I got this data. Some repetition is there. What I will do? What I will do? I will go for one list. I will take it. One list I will take it. For example, this is my data. And this A will not be remain same. A will not be remain same. Suppose if you feel A is remain same, I will take one LST. This code I already used to tell in the class. How to eliminate the duplicates? What is that? LST one empty. For value in where I say A. What is that? Value not in. Value not in where? LST. Value not in LST. LST dot what? Append of what? Append of what? Value. That's all. You print off what? What values are coming? What values are coming? Unique values are coming. Unique values are coming. This I said in my beginning stages only. You see what is coming. Truth value will be more than one element is an ambiguous. So it is first you try to apply here. Try to print the value first. Try to print the value once. So these are the values are coming and you need to take these values one by one. It is going to give you what? Complete row is coming here. Complete row. Complete row is coming. What you do is, as I already said to you in the class, you check it once for your satisfaction. A dot what? End. A dot end. 2. I will do what? For I in range of len of A. len of A. For j in range of LEN of A of 0. A of 0. This concept I already explained. It is very simple today. I comma j I will write it. I comma j I will write it. I got 0, 0, 0, 0, etc. So many things will come. That part I want to go for checking. What is that now? If A of what? I comma j. A comma I comma j is not in where? LST. What is my LST, students? What is my LST is equal to 0, empty. Not in LST. LST dot what? Append of what? A of what? IJ. A of what? IJ. Beautiful. It's IJ. Then come out, come out, come out. And print of what values? What values? Unique values. Unique values. Print of what? LST. LST. So I got it. Where is the bracket problem? Huh? Where is that invalid syntax? Is not necessary now. Not in that's all. Not in that's all. I got what values? Unique values. That unique values I want to go for what? ND array. ND array. I'll happily convert it into what? Come on. NP dot array of what? LST. NP dot array of LST. I got my values. Unique values, everything. Mr. Dheeraj. Dheeraj Kumara, what is that? Dheeraj or something. So unique values are getting or not? Yes. It's simple. Brain has to work. That's all. And your brain is super brain. Already it is under working mode only. So what is my code I written? Membership operator I used it. Membership operator. So coming to the point of it, Pawan Kumar, for me download option not showing in Google Classroom. Downloading notes. It's a very much danger. Downloading the notes is a very difficult topic that is. Actually, NumPy is easy. Downloading is difficult. Okay, let us to the point. Are you following me? Yes. Now I'm going to say, further I'm going to. But I can't say that how many unique values are going to come because say there are some values. When I put this in matrix, sir, I may not be able to keep it in matrix. Why? If you want, I can go for this use, take it. This example, if I take some x is equal to like this, if you keep it, x comma, what is this now? LEN of x. I cannot say that whether it is 27 elements are there. 27 element. Next time you run it, next time you run it, next time you run it, if it is 27 elements are coming, you can go for what? Keeping into formulations and combinations. 9 into 3, 3 into 9. The combinations you can use it or not. That combination also you can apply. So right now, I want to find out unique values. We got it. Okay now? So now I will move to the further. This is about which function? Which function? Shuffle function. Shuffle function. Got it out? Very good. Go to the next. You see, danger. Danger example. 3D, 2D changed. Rows changed. 3D I am going to take it. Very danger. What is that? See that. What is this now? A range of what? 48. 48 I am keeping into what? 4 rows, 3 rows, 4 columns, 4 matrices, 3 rows and total 4 into 3, 12. 12 into 4, 48. Understand now? Okay. Good. Print of what? A. Type of what? A. So exactly that 4 elements. 0 to 11. Like this. All of them are there. 4 matrices arranged. Now I'm going to do what? Shuffle. Shuffle. So here, random of shuffle. Be careful. Here I am writing what happens. This you take care. And print this A. Print of A and type of A. What is shuffled? You try to observe it. What is happening? You see. What is happening? You see. Total matrix. This is the first matrix or not? It went to where? It went to third. And 12, 16 earlier. 12, 16. Second is coming to where? First. Like that, is it reshuffled the total matrices or not? Matrices are shuffling. There rows are shuffling. Here matrices are shuffling. In case of what? 3D, 2D rows. In case of 1D elements. In case of 2D rows. In case of ND matrices. In case of clusters, clusters only will exchange. Clusters only will exchange, not other kind of things. Okay, now, right. This is about the concept of what? Concept of shuffle. Shuffle. Okay, now. So this is shuffling mechanism is done. So this I will stop my class. And with this, I hope number of approaches almost done. In the next class, I'll go for what? Choice. And after that, with this, all mechanisms are over. Next, I'll go for ND array advanced indexing. I will explain. ND array advanced slicing. I will explain. Very complicated concept. Monday class, I will enter into that area. Don't miss Monday class. Okay, students? Right. All the best. Take care.